Hey guys, in this video I want to talk about support vector machines or SVM. Just like many other machine learning algorithms, SVM also has a regression type, not only a classification. So like before, I fill the missing values with 0 and let's start with the basic implementation. Here I imported support vector classifier. Which is the SVC class from scikit-learn. Then I used the cross-value score with 10 folds, meaning I created 10 different SVM models and averaged their accuracy. So the output here is the mean accuracy across those 10 validations. As you can see, the accuracy is not very perfect and it's around 66%. Now let's go a little deeper. The SVM work with different kinds of kernels. We have kernels like polynomial, linear, sigmoid, and here I use the RBF kernel, which stands for radial basis function. And here the meaning of the parameters that we use. The kernel is RBF. This kernel is good at capturing complex nonlinear boundaries, and the gamma control how far the influence of a single training example reaches. A high gamma makes the model try to remember each point individually, which can cause overfitting. And a very low gamma makes the model too general, which can lead to underfitting. So usually we tune gamma between 0 and 10 during grid search. And C is our cost parameters. This is the penalty for classification. A high C makes the model stricter, trying to correctly classify every point, which again risks overfitting. A low C allows more mistakes but increases generalization. And the class fade, this becomes important when our dataset is imbalanced. In this example, I set it 0 to 0.4 and 1 to 0.6, giving a bit more weight to class 1. If my dataset was balanced, I could leave it as default, but in imbalanced cases, class weight helps a lot. Overall, just like decision trees, SVM also has the option to handle imbalanced data using class weights. Next, let's try another kernel. Here I used a polynomial kernel with degree 2. This means the model is trying to separate data using polynomial decision boundaries instead of linear or RBF ones. And the score you see here is the accuracy of that setup. When we compare, this is part of tuning SVM parameters. We try different kernels, the value of gamma, degree, and cost, and then check which one gives the best accuracy. And finally, let's perform a grid search to find the best parameters automatically. Here I defined a list of dictionaries for my parameter grid. The first one, the dictionary, supports the linear kernel with different cost values, and the second dictionary supports the RBF kernel with different gamma and cost values. The third one supports the polynomial kernel with degree 2. Then I used GridSearch with the 5-fold cross validation, and it means it will try every possible combinations of these parameters, train the model, evaluate it, and finally tell me which set of parameters gives the best accuracy. Running this, it takes time, and I pause the video, and after that we will see its results and which parameters was win, and what is our tuning results. And here are the results. That means the best performing model among all the tested ones is an SVC with a linear kernel, and the cost function equal 1, and the class weight that I specified earlier. In simple words, the linear kernel worked better than RBF and polynomial for this dataset. This doesn't mean linear is always the best. It depends on your data. That's why parameters tuning with GridSearch is very important. Finally, I just wanted to mention, like decision trees or KNN, SVM is also a very practical tool. It might not always be the very best for big data, but if used correctly with the right kernel and tuned parameters, it can perform really well. So thank you for watching this video, and I'll see you in the next one.